Right, good afternoon folks, welcome. My name's Tim, I'm Head of Research at Portcullis, and my colleague Mike helped me on this piece of research, so he's going to be chipping in where he feels I've missed things, and I'm going to be making sure he doesn't get sidetracked by the cats, as you'll see later in this presentation. So, what this talk's going to be about, what we tested, how we tested it, what we found and why it's bad. So what we actually tested was an off-the-shelf device from a company over in the States, a time server. It's fair to say that historically the people we were testing it for might have just installed an NTP package on their system, but the way their company had restructured, they no longer had that capability, so they decided they'd buy one. Probably not the best decision they ever made, and we'll discuss why in a little bit. All of these bugs have been disclosed to the vendor. In fact, the vendor is currently awaiting a conference call with us to discuss what to do next, because they eventually failed to get back to us, and we've been forced to publish them. So they're going up on our website today. The vendor's a little bit upset about that, but unfortunately they didn't actually get back to us within the requisite 6 months, was it?
Something stupid like that, yeah.
So who would buy a time server? Well, you can see a good list there. That's actually taken directly from the vendor's website. Unfortunately, we can't tell you who we were testing for, but if you think about it, anybody that needs to have accurate time, whether that's for trading, defence, medical purposes, whatever it is, ultimately they need to know that the clocks that they're using for their systems are correct. So the attack surface of the device we looked at, if you imagine it, it was a typical one-U system. It had USB, it had serial, it had network ports, it had some buttons on the front which were quite interesting. It had a management network, it had a production network, and it had some authorised applications that would allow you to configure the time server. Probably, I'd say the management interfaces weren't exactly required, but if you're buying something off the shelf these days, people expect to have a fluffy interface. So, in terms of physical attack surface, what we looked at, first of all we looked at USB. That had a number of interesting properties. It took updates, it allowed configurations to occur, and it potentially could be used for peripherals. If you think about it, it's, as you can see there, Monte Vista Linux. Ultimately it's just a standard USB implementation on Linux. So, physical. We looked at what the serial devices were doing at boot time, and whether they allowed console access. We didn't see anything particularly interesting during boot. We have seen devices where, for example, it's leaked information that have allowed us to ascertain how the ASLR implementation is functioning. And indeed, on one particular system, we actually managed to see the seed that was being used to seed the ASLR, which was kind of quite useful when we came to exploit it. In this instance, nothing particularly interesting during boot. In terms of console access, there was some, however. In terms of network access, there were 2 ports, LAN 1 and LAN 2. LAN 1, I think, was the external port, and LAN 2 was the management port. Different services on both of those. That was actually quite good. Typically, we often see that the same services are present on all interfaces. For once, they'd actually locked it down. We'll discuss what the attack surface actually looked like in a couple of slides' time, but it was better than we'd have expected. So physical, buttons. Most devices, 1U of type, will have some kind of buttons on the front, even if it's just to allow you to see the time or to locate the device, etc. In this particular instance, it gave us the ability to change some settings, make backups, and indeed, it had the property whereby you could set a pin which would lock it. Unfortunately, that was a kind of a case of, it was almost like a physical lock. If you didn't remember to lock it, it wasn't locked. And as you can see, based from the configuration dumps, because it wasn't locked on the device we were looking at, we were actually able to extract the pin, which obviously meant that we could then play with the interface in a bit more detail. So, logical. There was a web interface, which I think Mike's going to talk about in a second. There was SSH, there was SNMP, and there was Postgres. Postgres is particularly interesting, and Michael will explain why in a second, but you wouldn't necessarily have expected to see Postgres listing on the network. It's somewhat inadvisable, however in this particular case it was there.
Yeah, so on the management network there was a web interface, as you often find. That's what it looks like something from the 1990s. We have to blame Jake Costanza for this. He's clearly very proud of it. His name is everywhere. The source code of every page, built-in credentials as well. We'll come across those later. But yeah, that's a rough thing of what it looks like. If you go on Showdown, you can find a few of them about, but don't do that. Next. Yeah, so it was really good. It was fantastic. That's what we've got there. All of these were trivial to exploit. There was literally no mitigation against anything. So yeah, the list, to be honest, who cares? There's unauthenticated remote root there. There's proof of concept on our site, which is literally just a curl command. So if you come across one, you're on it, you've done it, owned, moved on.
Yeah, it was a little bit of my first PHP application, which is a bit of a shame for a device that ultimately only has one function to tell the time.
Yeah. Semicolon ID. Oh.
So, SSH. The SSH implementation was slightly different from what you may have expected if you played around with the Unix box in the past. They had a customized shell, but it turns out, having done a little bit of digging into how the shell binary works, that we could get into an engineering mode. And in fact, if you see the screen, I'm not sure that you will be able to, but essentially we've highlighted there's actually command injection into the shell. So the shell has a lockdown set of commands you're allowed to run. It does include copy, so it's not very well locked down, but it does have copy. But the way that it constructs, for example, the copy command, the way it constructs the ifconfig, etc., 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 means that if you pass in a semicolon and then a value of your choice, you can trivially get command execution. And from that, you can actually get root, because the sudo configuration is itself pretty terrible. Copy is allowed to be run as root, and it doesn't require a password. Ultimately, from a command interface, I guess you might expect that. Bear in mind that configuration was being applied to the web server, perhaps. It's difficult. They wanted to run things as root, and the moment you want to run things as root, you're pretty much boned. So this is the shell breakout we were talking about. So root and engineering, that was the bit we extracted from IDA. That was the bit that allowed us to get into the engineering mode. Sys took us into a menu that was for system commands. As you can see, we've got both CP and ifconfig. Both of those, ultimately, if you have a semicolon and then /bin/batch or whatever, will allow you to execute commands of your choice.
Yeah, looking at SNMP, there wasn't any write access, but with public, you could just pull off anything you liked. So there's lots of lovely information.
Kind of useful if you were attempting to exploit it. I don't think we looked to see if there were any custom MIBs. We couldn't find any, or certainly not any that were of any real interest. It's something that if you're looking at embedded devices, you should probably be looking for, because quite often you'll find that they have features that aren't part of the standard OID set. So we mentioned that Postgres was available over the network. And it became apparent why, once we'd compromised the device and we'd got the ability to look at things in a bit more detail. It turns out that part of the management interface for the web actually used the Java applet to draw some pretty charts that demonstrated what the statistics on the device were like at a given moment in time. Turns out, if you decompiled the Java applet, the credentials were in there. In fact, Jake Constanza's credentials were in there. And it turns out that it was directly connected back over Postgres. I mean, you've got a perfectly good web server. Why would you want to use it? Interestingly, they also did have another database server on there. They also had Firebird on there. They clearly weren't people that were thinking about minimising their attack surface in any way, shape or form. But, yeah, a lesson about how not to do things. So next we come to NTP. So NTP was the only service that was actually listed on the production network. That's quite good, I suppose. Turns out, though, NTP, you really only have one thing to do right. Make sure that it can't be used for denial of service, that you can't essentially send in a packet to it, which it then mirrors off to your original target. Turns out in this case they got that wrong. This is basic 101. If you're running an NTP server, you should be aware of this. And they've left the monolith command enabled. So it's safe to say we owned the box. We owned the box pretty quickly. We actually got into the box in the first instance through the original dumping of the configuration from the buttons on the front. From that, we essentially got a copy of ETC, which is how it backs up the configuration. We modified that and then re-uploaded it.
I think it's probably worth
stick.
pointing out the default credentials on the web interface.
Yeah.
The password was already in my John Pop file. I don't think this is the first time these have been owned.
So we got into it fairly trivially. And we started to have a look at how the OS had been configured. As I said, it was Montevideo Linux at the base, but obviously they'd done quite a lot of tweaking to make it how they wanted it for an NTP server. And we found two good instances of interesting bugs at a Unix level. Firstly, we found world writable files, so that anybody that had access, that shell user, even if they couldn't get through sudo, they could potentially have written files. And we found obviously the insecure sudo configuration itself, which allowed us to break out and get root, I guess. So ultimately, who cares? Which I guess is probably the most important bit of this. Our client clearly cares. Perhaps not as much as we'd have expected, because their intention is actually not to plug the management interface in at all. So they weren't too fussed about the web server because, yeah, they're never going to have it physically connected to any copper. All of us, this particular device, whilst I can't say who it was for, I can at least say that it was being used to synchronise domestic devices across the UK. So ultimately, you can imagine that if those devices are time sensitive, they need a clock. Possibly having an inaccurate clock across the entire UK may have some implications. And finally, this guy. So this guy appears on a mailing list that I'm a member of. There may be people that are here at EMF Camp will know this mailing list. But anyway, there was a discussion about what would be a good NTP server to use for an ISP, and someone mentioned Symmetricom. Curiously, they didn't have good words to say about it. We can certainly agree with them. We had the device randomly reboot 3 or 4 times whilst we were working on it for no apparent reason, not even the case that we were necessarily doing anything offensive. It did just seem to like to reboot.
Yeah, there we go.
No questions? Any questions? Did we open the box up? No, unfortunately our client wasn't willing to let us open the box. They were intending to put this on the network. As I say, they had intended not to put the management interface on anyway. So they wouldn't let us open it up. Had they done so, we probably would have gone after the usual things, but it was ultimately just a PC. So it's going to be the same attack surface as you'd find in your desktop or your laptop. So probably not as interesting as it might have been if it had been, for example, ARM or MIPS. So the question was, does this represent state of art in the time server arena? Well, I think state of art in the time server arena is probably just to install your own time server on Red Hat or Debian or whatever else. In terms of embedded devices, I think it's pretty representative of the kinds of things we see. Most of the stuff we do is for large commercial clients or large governmental clients. So most of the stuff we see is quite big iron embedded stuff. You know, maybe fridge-sized devices aren't uncommon for us to look at. And I think, yeah, the vulnerabilities will vary between vendors and devices depending on the function, but ultimately they'll all have similar kinds of bugs. No more questions? Well, thank you very much. Enjoy the rest of EMF Camp.